Hi folks, and welcome back to Physics with Captain Rod. I'm making this video here to help you out with problems 1 through 5 in your Unit 4 homework here. So these are all problems about charge and how it relates to the electron. So an electron, right, that's what this is supposed to represent in my picture, is a particle that carries a charge equal to 1.6 times 10 to the minus 19th coulombs. Now technically the charge is negative 1.6 times 10 to the minus 19th coulombs, but that's not important or relevant for any of these questions. So I'm just going to use positive 1.6 times 10 to the minus 19th coulombs for the rest of this discussion. And that's usually denoted with this little letter E here. It's called the fundamental unit of charge. So the way an object is charged is if you have extra electrons or you remove extra electrons. And every time you remove an electron, your charge changes by this value, 1.6 times 10 to the minus 19th coulombs. So the charge Q on any given system is some number which represents the number of either removed electrons or extra electrons times the 1.6 times 10 to the minus 19th coulombs. So in number 1 here, where it says common static electricity involves charges ranging from nanocoulombs to microcoulombs, how many electrons are needed to form a charge of negative 9.5 nanocoulombs? So I guess here in this problem they did include the minus sign, but it's again not important really for the discussion. So nano means 10 to the minus 9th. So this charge is equal to, I'm just going to write 9.5 times 10 to the minus 9th coulombs. And it has to equal some number times the 1.6 times 10 to the minus 19th coulombs per electron. And then you just solve this for n. Sorry about my crummy writing. Again, if you want to include the minus sign here because they did, then include it over here as well. Either way, you're going to get just a positive value for n. And you're going to get a pretty big number. Looks like it's going to be around 10 to the 10th power. Part B is done virtually the same way. You're given a value, and the one I'm looking at, it's 0.35 microcoulombs. Now micro means 10 to the minus 6 coulombs, and this is equal to n, some number, times E, the fundamental unit of charge, where again the fundamental unit of charge is this value. It's the charge on an electron. Okay, numbers 2 and 3, let me clear this up here. Numbers 2 and 3 are virtually identical. You're given a number, so a big number. In number 2, I see 2 times 10 to the 20th electrons. Again, sorry about my crummy writing there. How many coulombs of charge moved? And so the coulombs of charge is this, and that's going to equal n, that's the number given, times E, the fundamental unit of charge, the 1.6 times 10 to the minus 19th coulombs. And that'll get number 2 done. 3 is virtually the same. 7 is the same. And I'm sorry, 3 is the same, 4 and 5. These are all the same. And every one of these were given numbers. And then you take the number times the fundamental unit of charge to get the to the charge. Oh, actually, number 5 I do want to talk about a little bit more. I see it's slightly different. It's got what I would call a little league curveball here. So in part A, it says there are 6.33 times 10 to the 6th electrons and 8.61 times 10 to the 6 protons. So you see there are more protons than electrons. Now a proton and electron have the same charge, other than electrons have a negative charge, protons have a positive charge. So if you take the difference between these two numbers, technically including the 10 to the 6th, that's going to tell you how many extra protons there are. Okay? And once you know how many extra protons there are, then we can apply this. Q is equal to n times E, where this N is going to be the number of extra protons, and then the E will be the fundamental unit of charge, 1.6 times 10 to the minus 19th coulombs. So that should get you through problems 1 through 5. I hope you enjoyed. Have a great day.